Okay, for this first experiment, I call this the cookie cutter experiment. And you don't need that many materials for this activity. This is all you need. First, you're going to need some vinegar, which is a clear liquid. Then you're going to need some baking soda, which is a white powdery solid, and these are our two main components for this activity. So we get to see what kind of reaction happens when we combine this liquid with this solid. You're also going to need some liquid food coloring, and that's to help us color our vinegar. And you're going to need some holiday festive themed cookie cutters. I have a mitten, a snowflake, a tree, a candy cane, a gingerbread, just whatever I choose for this activity. You're going to need some sort of tub or container for all of this to take place in, to help with cleanup and to help with spillage. You're also going to need an eyedropper or pipette, as we call it here in the science lab. You'll need a spoon to pour and move your baking soda around. And last but not least, Ms. Bell likes glitter and glam and sparkle and jazz, so I am incorporating some shiny glitter to this activity. I'm excited. I hope you are too. Yay! Here we go. Okay, so the first thing I'm going to do is take 2 little cups and pour some vinegar in each. Now I'm going to grab some food coloring. I have red, yellow, green, and blue, and I'm going to just color this clear liquid vinegar. I'm going to try for like a lime green. I have my 3 dishes, and I'm going to put them inside. I don't know if I can get more than one. I can over here. This one's kind of smaller. Oh, perfecto. Yay. Okay, now I'm going to pour my white, fluffy, powdery baking soda into each of these cookie cutters. And so I'm using my spoon to make that happen. And I'm going to try, keyword try, to keep the baking soda inside my cookie cutter area. Is it okay if I get a little bit outside? Of course. This is science. Sometimes it gets messy. Sometimes when you make a mistake, you find out it actually kind of turns into something else, and you get to visually see what that mistake looks like. So I'm just going to take this time to fill in all of these ornaments. Okay, now I'm going to take some of that shiny glitter that I am wanting to incorporate, and I'm going to add that on top of my baking soda. While I'm doing this, I just want to think to myself, what is my prediction on what's going to happen once I add my vinegar that has been colored with food coloring? What kind of reaction do you think is going to happen, if anything at all? Well, I am going to predict that my baking soda is going to change color, because I know I added all that food coloring to my vinegar. And all this glitter that I'm adding, I don't know, I think it might do something. It might look like it's dancing, or it might like pop around. So that is my prediction. Okay, I have my tree, my bell, my gingerbread, my snowflake, and my mitten. Now I'm going to take my liquid vinegar that has been colored, and I'm going to add it to all of my cookie cutters, and we're going to see what kind of reaction happens. Are you guys ready? Thumbs up. I know I am. Here we go. Look at all of that. Oh my goodness. This is so cool. Whoa, look at all the bubbles. I wasn't so sure that all of this would really stay in the cookie cutters, but I am highly surprised and amazed that it's doing that. Whoa! Look at that reaction! Oh! Just think about what it would look like if I kept adding more and more and more vinegar. Whether it was colored or not colored. Oh my goodness. This... Whoa! Is this what you imagine would happen whenever I added the colored vinegar? Did you think you'd see all these bubbles and it foaming? Miss Bell is curious now. The scientist is coming out to explore. I just want to pour vinegar by itself from the bottle. Whoa! Oh, Miss Bell poured too much. That's cool how it exploded and it went over just like that. Okay, I'm gonna come over here and I'm trying not to pour too much. Whoa! Oh, good, I didn't pour too much right there on my gingerbread. Whoa. Oh my gosh. Whoa. Oh, I didn't mean to do that, but it looked kind of cool. Oh, that is fabulous. So not only did they get fizzy and bubbly, but it was just so cool to see all the colors mix and to see those reactions, those chemical reactions happening between the vinegar and the baking soda. Look at that! It's amazing! Look how high this is. I can pop it with my finger. Boop, boop, boop. And glitter is sticking to my finger from the bubbles that are being created from that chemical reaction. So for this next activity, I'm really excited about it because my kiddos at home have made it themselves, even though I didn't participate in that activity. They loved it. They were upset when I said it's time to stop and clean up, but when you're talking about this particular activity, you need to keep in mind the differences between a solid and a liquid. Solids are very unique in their own properties. They can be hard, they can be soft, they can be squishy, but they have their own shape. Take for instance my tape roll. It has a shape, you know. I can do something to change what it looks like. I can bend it and squeeze it and do this and that. Or my peppermint right here, it's round and kind of flat, and I can crunch it up if I want to change what it looks like. But those are examples of solids. But take for instance my water right here in my bottle. It is taking the shape of the container that it's in. It doesn't have a shape of its own because it's so fluid and it moves around. If I were to spill my bottle, the fluid, my liquid, would go all over the place. But if I just kind of drop my peppermint on the table, it's not going to spill everywhere like a liquid would. So that's kind of the difference between solids and liquids. But with this activity, I'm going to show you guys how to make something that resembles the properties of both a solid and a liquid. And this goo, as I'm going to call it, that I'm going to make has a name, and we call it oobleck. This goo will at sometimes look like a solid if I squeeze it, poke it, and pick it up and touch it. But if I have it in my hands and I just leave it alone, or it's in my container and I'm not messing with it, it'll have like liquid-like properties. It's so cool. Maybe you guys will get to make it at home and play with it at home, but you don't need a lot of materials for it. That's what makes this activity and this goo so fun to make. So you're only going to need cornstarch, and you're going to need water. Because this is a holiday themed activity, I'm going to use peppermints because I want to see if I can extract all those red colors from my peppermint into my oobleck goo. And I'm going to play around and add some little cute little holiday frozen toys as well. You're going to need something to stir the water and the cornstarch, a spoon. And you're going to need something to measure. Here I just have a measuring cup. And you're going to need something to play around on, whether it's a flat tray like this or just a table that you don't mind getting messy on. And you're going to need something to mix all of those items in, whether it be a bowl, a tub, or like I'm going to use a beaker. So let's get started. So what you're going to do is take your cornstarch in whatever measuring cup that you have, and you're going to want to stick with a certain ratio, a 2-to-1 ratio. And basically what that means is, let's say you're using a 1 cup measuring cup. So you would have 2 cups of cornstarch to 1 cup of water. And you would stir those 2 ingredients together and then make adjustments along the way. If it's too stiff, you add more water. If it's way too liquidy, you add more of the cornstarch. And you just keep stirring and stirring and stirring and mixing until you get a proper consistency, kind of like this. It's runny and gooey, but not too stiff and not too liquidy. So now I'm going to take all of my oobleck glue and try to move it from my beaker container to my flat tray right here. And as you can see, it looks like a solid on my spoon and it's dripping down, but on the tray, it's starting to spread out like a liquid. See how it looks like really chunky right here? But then it's ooey gooey like oobleck. So I'm going to set that aside and I'm going to start incorporating. Ooh, they just sink in. Oh my goodness, that's so cool looking. You can hear a little thud too. I can move my oobleck all around. I could use tweezers like this to move it. I can gather up some and squeeze it like this, and it forms a little ball. I can shape it, but as soon as I let go, it starts dripping down. So the next thing I want to show you guys is a trick that you can do using science. And what I'm going to do is take my little holiday tree right here and make it look like it's being levitated or lifted up into the air and moved side to side and back and front, but I'm not going to be touching it. I'm going to be using science to be moving my tree. And you might think, what kind of trick is this? What is she doing? I don't understand. But soon enough, you will see how I get my tree to look like it's levitating. Look at my tissue paper trees. Do you see how they're being lifted up into the air and moved from side to side without being touched? Why do you think this is happening? What would be your guess? How about I zoom out to show you what's really going on? Oh, did you guess that I was using a balloon to make all of this happen? Do you remember when we studied magnets way back when? We learned that different poles will attract, like positive and negative, while similar poles, like positive and negative, will push away or repel away from each other. Well, when you rub a balloon on something, like my sweater or something similar, it will generate static electricity. That's a big word. I'm going to say it again. Static electricity. Well, it kind of acts like a magnet with all of these different charges, positives and negatives. A static charge forms when two surfaces touch each other and the electrons move from one object to another. And when I say moving from one to another, it's almost like frogs out in a pond jumping from this lily pad to that lily pad to this lily pad to that lily pad. So they're moving from one object to another. So when I rub the balloon on my sweater, some of the electrons from my sweater move onto my balloon. And this gives the balloon kind of a negative charge. And this is very helpful because my balloon can then pull an object with a negative charge, like my little paper trees, towards it. As you can see, the trees are able to stay grounded to the table because they're connected with some tape. But what would be your prediction about what it'd look like if they weren't taped down to the table? What do you think would happen to those paper trees? Well, in science, there's only one way to find out, and you've got to put it to the test. Let's see what happens when I take off the tape and try it out. So for this next holiday themed activity, we are going to make a frozen glove. And we're going to play around with heating and cooling or freezing and melting, and we get to have some fun with frozen characters. So these are the materials I'm going to need for my frozen glove activity. I'm going to need some water that I'm going to choose to color blue with food coloring. I'm also going to add in my glove, which is what you need. Just some fun, festive, holiday, frozen themed trinkets. So I have some frozen little plastic toys that are my daughter's toys. I have some different colored glitters. I have some star confetti, and I have some blue sequins. Whatever you can find, if you want to make this at home, anything to just make it that much more festive. But I'm also going to need a spoon to stir my food coloring in, and I need a rubber band to tie off my glove at the very top so that none of these liquids or solids escape from my glove. And last but not least, I'm going to need some sort of tray to put my glove on top of so that it's easy to transfer it to the freezer for it to stay in there and freeze. At the very end, we can come back and we can incorporate any type of heat source to melt our frozen glove. You could take it outside and use the heat energy from the sun. You could bring it inside and use a heat lamp. You could, what would you do? What would you use? You could use a blow dryer. There are a lot of different options of heat sources to use to melt your frozen glove. So the first thing we're going to do is color our water blue with blue food coloring. Then I'm going to stretch that glove over some sort of container to hold it open while I add all my fun fillings. I have glitter and confetti and sparkles and sequins, and slowly I'm just adding that water into the glove with all of those fillings. I'm mixing it around while holding the top opened part of the glove closed so that none of the liquid escapes, and then I'm just adding more and more as I go. And at the very end, I'm going to take a rubber band and tie off my glove, and then it will be sealed so that I can move it all around to try to evenly spread out the fillings. So I'm going to put my plastic glove in the freezer overnight so that the liquid freezes into ice. Then the next day I'm going to take it out of the freezer, cut the plastic glove off, and then I have a solid block of ice like you see right now. It went from a liquid to a solid as we reduced that heat, so it froze. And first off, I'm going to have a blow dryer adding heat onto my block of ice. We can see how our frozen glove or our chunk of ice is slowly starting to melt. Now I know these videos are quick and it allows us to see a time lapse of melting, but this is actually kind of a slow process depending on the type of heat source that you use. If you let this chunk of ice sit out in room temperature, it's going to melt a lot slower than if you bake it out in the sun or if you put a hair dryer up close to it. But right now, this is my second source of heat energy. I'm using a lamp that you plug into the wall to add heat to my chunk of ice. You can see the water dripping. That's just a sign of that solid form of ice melting back into a liquid state.
So, as you can see, this is all that's left of our frozen glove after we added heat in the form of either our hair dryer or our heat lamp. So for this activity, we get to work with candy canes. I'm so excited to do this activity. I call this the dissolving candy canes. And what I mean by dissolving is some sort of item like our sugary sweet goodness over here sort of becomes part of a liquid. So I'm going to take candy canes out of their plastic wrap and place them into 5 different types of liquids. In fact, those liquids are warm water, cold water, vinegar, vegetable oil, and lemon juice. And as our yummy, sweet, delicious, minty candy canes take a bath in those 5 liquids, we are going to make some observations along the way. We're going to use our sense of sight to look at those candy canes as time passes, and we're going to see what kind of changes or reactions, if anything, happen to our sweet, sweet candy canes. What do you think might happen as they take a bath in their liquid? Will the stripes turn into polka dots? Will they be broken into a million pieces? Will they disappear? Who knows? That's what's so fun about science, especially with dissolving sugary, yummy candies into different liquids. So before I start setting up all of the materials for this dissolving candy cane activity, I want you to make a prediction, which is just a guess. So our testable question is, which liquid do you think will work the best by dissolving a candy cane the quickest? And your answer would be one of those 5 liquids. Is it warm water? Is it cold water? Is it vinegar? Is it vegetable oil? Or do you think the lemon juice would do the best? And so my answer would be, I predict that will dissolve the candy cane the quickest. I know what my guess is. What's yours? So when all is said and done and the experiment is over with, we were able to observe that the warm water did the best. So we can take what we know and fill out a CER, or in science, as we call it, the claim, evidence, and reasoning. My claim is that the candy cane dissolved the quickest in the warm water. My evidence, well, I observed the red stripes disappear first in the warm water. Also, the candy cane itself first broke in half in the warm water. And lastly, my reasoning. This shows that warmer liquids just might dissolve sugary items quicker than cooler liquids.